This screencast covers impact craters. It is a nice follow-up to the screencast that I have already recorded for asteroids and comets. So do asteroids and or comets periodically hit the Earth? Yes, they do. Here is, first of all, an aerial photograph of the first impact crater definitively identified at the surface of the Earth. This is a nice aerial photograph of what was originally called Barringer Crater, but is now simply referred to as Meteor Crater. It's in northern Arizona. It was formed about 50,000 years ago. The impactor was an iron asteroid, maybe about 150 feet across, weighing several 100,000 tons. The American geologist who is responsible for the study of impact craters at the surface of the Earth was Shoemaker. He definitively proved the existence of impact craters on the Earth, and he definitively proved that Meteor Crater, in fact, is of an impact origin. That's where he did much of his early work in his geological career. Here's a nice close-up shot from the rim of Meteor Crater. The crater itself was originally about 800 feet deep and about 1 mile across. The impact occurred about 50,000 years ago. Today, the crater is partially eroded and partially filled in. Okay, this is a photograph of a rock that is at the rim of Meteor Crater, and just take a look at this rock. This rock was formed by a process referred to as shock metamorphism, and the energy density necessary to form such a rock exceeds far beyond that of geological processes such as earthquakes and volcanoes. The only energetic mechanism that we know of that is able to produce such a rock is an impact delivery. The energy density necessary to form this rock is well above that of geological processes. This rock, by the way, was originally deep underground and was excavated during the formation of the crater. And this right here is a microscopic photograph of a form of quartz called coesite. Coesite is considered to be the smoking gun of impact because the energy density that is necessary to form this intensely squeezed form of quartz is far beyond that of geological processes such as earthquakes, volcanoes, and so on. Once again, the only mechanism that we know of that can form this particular mineral is an impact delivery of some sort. So the presence of coesite is considered to be the fingerprint of impact. Coesite was first identified around Meteor Crater by Shoemaker. Okay, since Shoemaker's work, we've identified several hundred craters scattered around the world, impact craters that have been formed by an impact origin. At times, however, craters are difficult to identify due to erosion. Many more, quite frankly, probably lie buried underneath ocean sediments. Here is the largest impact crater that's been identified on the Earth. It's in South Africa at a place called Vredefort. It's 300 kilometers across. It was formed 2 billion years ago, which is well before the evolution of multicellular life on Earth. The asteroid or comet that formed this impact crater was at least 10 kilometers across. Here's a nicely preserved impact site in Australia called Wolfe Creek. There's another one in Australia here called Gosses Bluff. Australia is a desert today, and erosion processes take place slowly in deserts, so then therefore that has resulted in the preservation of these impact craters for us to see today. Okay, this right here is an elevation map of a portion of Bavaria in Germany that's referred to as the Ries Basin. It's 25 kilometers across. The crater itself is somewhat difficult to spot at the surface, however, because it's partially filled in and also due to erosion. Right here is a photograph of the Ries Basin from the surface of the Earth. It basically looks like a depression when you're standing right next to it. The basin was formed 15 million years ago. It turns out that right next to the Ries Basin is a small crater called Steinheimer. It's only about 4 kilometers across, and you can see the central peak that is still here associated with this crater. This crater was formed at the same time as the Ries Basin. We believe that the impactor that formed the Ries Basin had a small satellite that then formed this nearby crater, which is once again 4 kilometers across. Okay, here are a few other examples of impact craters that have been identified at the surface of the Earth. Okay, this is Manicougan in northern Canada. It's 60 miles across. The crater rim has collapsed to form a ring lake. This is a photograph that was taken from orbit. And then there is very famously the dinosaur killer, if you will, called Chicxulub, which is on the northern edge of the Yucatan Peninsula in Mexico. The crater itself is 150 miles across. It was caused by an asteroid that was probably 10 kilometers or so in diameter. It dates back to a time of 65 million years ago when a mass extinction occurred at the surface of the Earth, resulting in the extinction of the dinosaurs. So this is the smoking gun, if you will, of the extinction of the dinosaurs. This is basically what killed them off. It's located here, as I mentioned earlier, on the northern coast of the Yucatan Peninsula in Mexico. The impact itself wiped out about 90% of the Earth's species, clearing the way for the evolution of mammals. So, quite frankly, because of this event, we owe our existence to this event today. Okay, here's not really a photograph per se of the Chicxulub crater. It's heavily eroded and it's not easily identified. The crater itself wasn't discovered rather until the early 1980s. This is basically a map of ground penetrating radar that reveals the remains of the crater. Once again, it's about 150 miles across or so. Okay, here's another reason why we know, for example, that the extinction of the dinosaurs occurred 65 million years ago, even well before the discovery of the Chicxulub crater. This particular rock layer is called the KT boundary, and it dates back to a period of time 65 million years ago between two geological periods. Below the layer of rock is what's called the Cretaceous. Above the layer of rock is what is called the Tertiary. Okay, the layer of rock itself contains a high concentration of the element iridium, which is rare on Earth, but it's common in meteorites and asteroids, and it's found worldwide. Dinosaur fossils, for example, are found directly below this layer, but there are no dinosaur fossils that are found above this layer. So the formation of this rock layer worldwide basically marks the extinction of the dinosaurs, and basically it's the debris, if you will, that was kicked up in the ejecta of the asteroid impact that occurred at Chicxulub 65 million years ago. Yeah, there's been speculation for years that another extinction event occurred near the end of the last ice age, roughly 13,000 years ago, and we believe that this extinction event was in fact caused by an impact of an asteroid. Okay, there have been, for example, nanodiamonds, very small diamonds that are microscopically small that have been found scattered around the Earth, and they date back to this time. We believe that these nanodiamonds were formed in the actual impact that occurred at this time, but it did take some time to find the crater associated with this impact because it's partially buried. Here is that crater. It's actually in Greenland. It's partially buried beneath the ice sheet. It is 19 miles wide, and it was formed almost 13,000 years ago. So this event resulted in the extinction of many large land animals in North America in particular, such as woolly mammoths, mastodons, giant sloths, and so forth. They all basically disappeared around this time, and it was probably due to this mass extinction event. Okay, do impacts continue to cause wreckage on the surface of the Earth today? Yes, they do. Here's a famous example from just over 100 years ago in a remote region of Siberia called the Tunguska River. We believe that a cometary fragment blew up over Siberia and it caused widespread devastation for hundreds of kilometers in all directions. You can see here all of these trees that were flattened in the actual explosion. The blast itself released more energy than that of a small atomic bomb, and we believe that it was caused by a cometary fragment basically blowing up a few miles above the surface of the Earth. Here is a near miss that occurred in Wyoming in 1972. This was photographed by a tourist at the Grand Teton National Park in Wyoming, and it basically, as you can see right here, is a photograph of a near miss of a small asteroid that is basically skipping off the Earth's atmosphere. We estimate that this meteor was about the size of a small house. And then an event just about 8 or 9 years ago occurred in Russia at a city called Chelyabinsk. This was another near miss where a meteor basically about 65 feet wide or so exploded about 16 miles above the ground. It damaged thousands of buildings in this city and it injured hundreds of people. Okay, then here's a famous impact that occurred at Jupiter back in 1994. A small comet swung by Jupiter in 1994. It's called Comet Shoemaker Levy 9. It was, by the way, partially discovered by Shoemaker. The comet itself was torn up into about 20 different fragments by Jupiter's gravity, and then a couple of months later, each of these fragments basically slammed into the planet, and the whole world was basically watching with telescopes at the time. So right here is an infrared photograph of Jupiter just before one of the fragments hit the planet, and then just after. This fireball that you can see here in this infrared photograph is actually larger than the Earth. So over the course of a couple of days, about 20 fragments of this comet slammed into Jupiter. Here's a visible light photograph of one of the scars that persisted in Jupiter's atmosphere for several months after the impacts occurred. No craters, however, were formed during these impacts because Jupiter is a gas giant. After the SL9 impacts on Jupiter occurred, scientists quantified the danger associated with an impact on the Earth. And the scale that they have devised is referred to as the Torino scale, and it's basically, if you will, an estimate of the amount of damage that possibly could be caused or the hazards associated with an Earth-crossing asteroid. So, for example, an asteroid that rates a 0 on the scale has 0 or virtually 0 chance of an impact. An asteroid that rates a 10 on the scale represents a certain collision causing a global climatic catastrophe or a mass extinction event of some sort. So have we ever seen anything on the Torino scale since it was devised in the 1990s that is something greater than 0? Yes. Right here is a radio photograph of an asteroid, an Earth-crossing asteroid called Apophis, about 1,200 feet wide or so. It periodically swings close to the Earth as it orbits the Sun. It will come within 25,000 miles of the Earth in 2029. A few years later, it will be close again in 2036. And then actually in 2068, there actually is a small chance that Apophis could actually hit the Earth. Right now, because of refined measurements of Apophis's orbit, the odds of Apophis actually hitting the Earth are extremely low, something like 1 in 150,000 or something like that. But when Apophis was first discovered back in the early 21st century, it initially was rated as a 4 on the Torino scale. So let's go ahead and jump back to the Torino scale for a moment. Something that's rated as a 4 is a close encounter with at least a 1% chance of regional destruction. So when Apophis was first discovered, its initial placement on the scale was a 4, but additional measurements of its orbit have now placed the chances of Apophis as hitting the Earth as extremely remote. In 2068, there is the possibility that it could hit the Earth, but once again, it's something like 1 in 150,000. All right, so that's a brief look at impact craters and hazards associated with asteroids and comets here at the surface of the Earth.